We're live.
Operator, are you?
Yep, the call is being recorded. If you have any objections, disconnect at this time. Thank you.
Well, hello, everyone. This is John Clute, K4SQC, and I am your amateur radio moderator for today's ARISS, Amateur Radio on the International Space Station Contact. I am speaking to you from my home in Sandpoint, Idaho. What makes this contact a little different from the usual ARISS contact is everyone involved in this contact will be speaking to you either from their home or from the audio-visual room at the school as we all work with COVID-19 restrictions. With the help of the amateur radio volunteers and the crew on the ISS, we hope to soon establish an amateur radio contact with the International Space Station as it flies more than 200 miles above the Earth over Belgium. This contact will be performed using the Amateur Radio Telebridge Network, a worldwide network of amateur radio ground stations that enables students to contact the ISS. We are joined today by Kristen Fuqua, the teacher, as well as Stephen Taylor, W1HQL, the ARISS Amateur Radio Technical Mentor, who helped set up this call. We have a short video from Kristen introducing the students and telling us about the school. Steve, you want to go ahead and run that video, please?
Good morning. Welcome to McConnell Middle School. My name is Clint Chatham. I am principal, and joining me today are Wanda Rice and Kristen Fuqua, our sponsors of our Amateur Radio Club. McConnell Middle School is a Gwinnett County Public Schools of 6th, 7th, and 8th graders. We're located just 30 miles northeast of Atlanta, Georgia. We're glad you could join us today and excited about this live event. Amateur radio on the International Space Station has truly brought real-world learning to our students. Over the last year, our teachers and students have worked on activities to see the connection between space exploration and their learning. This event will have lasting impact on their lives. Thank you for allowing us to host this event, and we hope you truly enjoy it.
Hi, I'm Wanda Rice, KN4SSJ, and I'm one of the current sponsors of McConnell's Amateur Radio Club, or MARC, and I'm also a 8th grade physical science teacher here at McConnell Middle School. About 6 years ago, we established an amateur radio program in our school in partnership with our local ham radio club, the Gwinnett Amateur Radio Society, or GARS. Several people were instrumental in helping our club, including GARS, the educational liaison, Ralph Pickwick, and former teachers Jean DeLashmet and Dr. James Reeves. Our club call sign is KD4TGR. So far, we've been able to help approximately 30 students earn ham radio licenses, including one student that has gone on to obtain her extra license before she graduated from high school. We have participated in several ham radio school club roundups and have been able to make contact in the contiguous United States. The Gwinnett Amateur Radio Society is invested in bringing awareness of amateur radio to schools in Gwinnett County, Georgia, and is actively seeking schools that are interested in pursuing an amateur radio club.
Hi, I am Kristen Fuqua, and I teach 6th grade earth science here at McConnell Middle School. We were originally scheduled to have this ARISS contact this past April, but the COVID pandemic postponed our contact. Some of the students in today's contact have since moved on to high school, but they will be with us as part of today's program. We want to thank the people at ARISS for the opportunity they have given us to talk to Captain Cassidy today as he takes time out of his busy schedule to answer our questions. The work that ARISS does to promote space exploration for students is truly a gift, and we appreciate it. Thank you.
Well, very good. Thank you for that introduction and letting us know what's going on with the school. So thank you for sharing that with us. ARISS is an international program supported by amateur radio operators from around the world. Some member organizations of ARISS are the American Radio Relay League, the Worldwide AMSAT Amateur Radio Satellite Corporation, as well as space agencies such as the Canadian Space Agency, the European Space Agency, the Japanese Space Agency, the National Aeronautics and Space Administration, and Roscosmos, the Russian Space Agency. The amateur radio ground station that will contact with the ISS is ON4 ISS, located near Antwerp, Belgium, and operated by Jan Popelers. Jan, please tell us a little bit about your station and how you will handle today's contact with the ISS.
Thank you for the opportunity to introduce myself and my station. So the station, amateur radio station that assists you today with the radio link to the ISS is located in Belgium and situated in the southern region near Antwerp in the town of Mathew. This amateur radio ground station is kept operational by the UBA section AAA, the Antwerp active amateurs. In the realization of this Irish telebridge radio station are 6 volunteers direct involved. We're using two-way radios, fully computer controlled for frequency control, and antenna tracking both in elevation as in azimuth is also computer controlled. So my antennas are already pointed in the direction of reception. We expecting to receive Chris in 262 degrees west. So we're waiting for his approach over the horizon. And when I start calling, well, it can happen that it takes a few times before we have established contact, and you are receiving normally noise when there is no signal from response. I gave you a little introduction. So that is what you hear normal when I start calling. And that is, in short, John, what this station will do for assisting in the Irish contact today.
Very good, Jan. Thank you for that discussion. One of the things that we would like you to know is about 6 hours before we scheduled this contact, before this contact was to happen, the ISS did what's called a boost maneuver to change its orbit a little bit. And so there's going to be maybe a little bit longer than usual with Jan calling to try and to make the contact. A normal sequence, but always makes it a little challenging when the orbit is changed just a little bit before we need to make the contact. Today's contact, as you know, is with astronaut Chris Cassidy, KF5 KDR, who will be using the call sign, ISS call sign OR4ISS. The American Radio Relay League has provided us with a short video that tells us a little bit about the ARISS contact and how it all happens. So let's all watch that video. Steve, please go ahead and run the ARRL video.
Hi, my name is Ruth.
And my name is Chris.
You must be pretty excited to talk directly with astronauts on the International Space Station today. While we're waiting for the space station to come over your portion of the sky, let's talk a little bit about how it's going to happen. Of course, Mission Control is in contact with astronauts all the time, using a big radio with lots of fancy equipment.
However, we're going to be using something very different today. We are going to use ham or amateur radio to talk directly to the International Space Station.
When most people hear the word radio, they think of a music radio station, but it's so much more than that. Radio actually refers to the unseen energy that transmits all sorts of signals using electromagnetic waves. At first, people learned how to send signals like Morse code, and then they discovered that you can send so much more, like data, computer signals, and even TV.
Maybe you don't realize it, but you use radio every day. Maybe you watched the TV this morning, or you texted your friends, or maybe even you check social media like Twitter or Instagram.
Let's travel back to space for a minute. Since the beginning of the space age, humans have sent many spacecraft out into the universe. These range from the Hubble Space Telescope orbiting the Earth daily, and the Curiosity rover exploring Mars. We've even sent a long-distance messenger, the Voyager 1, who has traveled outside of our solar system.
Whether it's capturing a great picture of a far-off galaxy or conducting experiments on the space station, radio has to do with all of these. And today, you're going to be using ham radio. Now you might be wondering, what exactly is ham radio?
Amateur or ham radio is a service and a hobby where operators can talk with people around their neighborhoods, their cities, their country, and even around the world. Amateur radio operators require a radio license from the government. They're not that hard to get. I have one. My call sign is KM4LAO.
And mine is KD8YVJ. Our call signs are a way of identifying who we are to other operators. This lets everyone know that we have the proper license to using the radios.
As amateur radio operators, or hams as we are often called, we can talk with others about basically whatever we want, often science or some new radio gadget that we are interested in.
Let's focus back to the space station and your contact today. Many of the astronauts and cosmonauts aboard the space station are licensed ham radio operators. That's why your operators today can contact them. The people here, as well as the astronauts, are licensed to talk to each other, and you are allowed to talk over to their radio.
For our conversation today, we'll need an amateur radio station on the ground, either in this location or somewhere else around the world. We'll also need a radio in the space station.
Anyone SS.
You can hear the calls coming. This is November Alpha 1 Sierra Sierra, the International Space Station, over.
On the space station, the radio transceiver is connected to an amateur radio antenna mounted on the outside. One of these antennas will be used today during our contact.
For our side of the contact, we need a good-sized antenna, a signal amplifier, something to make our signal stronger, and a rotator for turning our antenna. We have to keep our antenna pointed right at the International Space Station. And remember, it's moving across the sky and fast.
To aim the antenna properly, we need to track the path of the space station exactly. NASA uses complex systems to track the path of the space station and other orbiting objects.
The satellite tracking program we are using works out a complicated set of mathematics to provide the orbital location of the space station moment by moment as it moves through space. This information is sent to the computer that controls the antenna rotator, which moves the antenna to follow the space station. Maybe some of you have seen or worked with robotics. That's pretty cool stuff. And just like you can program a robot where to go, what to do, and how to get there, you can also program a computer to tell an antenna how to track the space station across the sky.
You know, it took a lot of planning to get this contact. Several weeks ago, the ISSY operations team had to figure out when the space station's orbit would pass over this location. Then, they had to talk with the planners at NASA's Johnson Space Center. The crew's time is pretty full, so they were able to find a time that could work for the crew members' schedules. Once they found times that would work both in space and here on the ground, the host organized this contact. And in just a few minutes, you'll be hearing and talking to the astronauts.
Well, it's almost time for your contact. It will be exciting, so good luck with it.
Well, I hope that helps everyone understand a little bit what we're working with here and the complexity and indeed it takes a worldwide team to put this together. We are working with COVID-19 restrictions, which means that some of you are at home. So please remember that if a dog barks or little sister cries, these are just the sounds of home as we all work with the current situation. Remember, what we're doing here on the ISS is an experiment, and as all experiments, we never quite know the result until the experiment is finished. Students, very important, please remember to say over as you finish your questions. In about 2 minutes, the station should be over Jan Station in Belgium. So Jan, I'm going to turn it over to you, and good luck with the contact.
Yeah, okay. Thank you, John. Well, in my projection of the trajectory is not direct in popping up over the horizon. So we have a little bit, little 3 minutes to go, John, at the moment.
Okay, so we're 3 minutes out, and basically what's happening is we're just going to all wait. An ARISS contact is dependent upon line of sight communication. The ground station needs to be able to see the ISS for the contact to be successful, and we will hear it from the moment we see it. That's called AOS, acquisition of signal, and then we will follow it through until the ISS drops over the other horizon, and that's called LOS, loss of signal. And depending where we are in the questions, sometimes we get through all the questions, sometimes the last couple questions get lost as we lose the ISS going over the horizon, but those are all normal. If there's time at the conclusion, if we still have signal and all the students have asked their questions, we've asked Kristen Fuqua, the teacher, to give Commander Cassidy a thank you, but whether or not that happens really depends on how many questions we get through and how long we still have that signal. I show 14:16:43, so we're probably somewhere within 1 to Jan. How much time do you show to AOS?
1 minute.
All right. Would you like it back, and would you like to begin making your call?
Well, I can explain that we make an exceptional contact today. Normally we make IRISS contacts in VHF, and today we using an UHF communication frequency, and that's a rare situation. That's not always happened, but that is there is also a SSTV transmission on board, and that's the case where we avoid interference and that we use the UHF frequency, John. So that's in short what I want to explain in the special situation. And my antenna is direct appointed to the accepted direction, and we work in flip mode. It means the ISS going over the north side of my station. So it's my station is situated approximately in the 51 parallel, and the inclination of the ISS is also 51 degrees, and that makes the opportunity that it's coming just above my zenith in maximum elevation, and that's a good chance to do. But I think that it's the moment that I start calling, and we're waiting for a response for Chris. So this station is Oscar November 4, India Sierra Sierra, calling Oscar Romeo 4, India Sierra Sierra for an ARISS contact. How copy, over?
Oscar November 4, India Sierra Sierra. This is Oscar Romeo 4, India Sierra Sierra. I read you loud and clear. Great to talk to you. Over.
Okay, Chris, thank you for reply. We have students here from the McConnell School. Are you ready for questions? Over.
Ready for questions. Over.
So students, go with. Over.
This is Sydney. Are there special activities designed for you to help relieve the stress of living and working in space? Over.
Hi, Sydney. We generally use the exercise devices for that. We get a half hour to ride on a bicycle or a treadmill, and then it takes about an hour to do weightlifting, and I think all of us they see that as a stress reliever. But in addition, we just hang out with our crewmates and talk and laugh and share meal time together. That also goes a long way for relieving stress. Over.
This is Tiffany. Describe what surprised you about Earth when you got to the ISS. Over.
Tiffany, when I got to ISS, Earth surprised me in that there's really just a couple of colors you see, brown, blue, and white. Different shades of those, of course, and the ocean has slightly different shades of blue, for instance, when you go over the Caribbean, and depending on the time of year, the browns and the greens are different, but it's just so simply beautiful. It's all that I can describe it as. I was in awe of watching Earth go by beneath me. Over.
This is Jalen. Do you see evidence of recent West Coast wildfires or other environmental situations? Over.
Jalen, we absolutely can see those fires and all of the environmental situations. Volcanoes are another one that are impressive to see from up here. But more recently with the fires, it has been unbelievable to see how vast of an area the fires themselves are impacting, and then where the smoke travels with depending on the wind conditions. Unbelievable. Over.
This is Patrick. As a middle school student, what can we do to prepare ourselves for the job that you do today as an astronaut? Over.
Well, Patrick, to prepare yourself to be an astronaut or anything you do in life, I think it's the same thing, and that's be a good person, be a good teammate, be a good friend, be a good student, be a good son, daughter, and put forth your best effort in whatever you're endeavoring to do. And if you give all your effort, then you have nothing to be. You're living your best life, and that goes in school and as well as those other roles that you have that I mentioned. So just continue to be the great person that you are, Patrick. Over.
This is Mackenzie. In the movie The Martian, Mark was trained as a botanist. What is your area of interest, and what experiments are you doing in your field? Over.
Oh, Mackenzie, my area of interest is more on the operational side. I enjoy going outside and doing spacewalks or using the robotic arm that, for instance, we just captured a cargo vehicle yesterday or the day before, and that's what my area of interest and my sort of specialty lies. And with experiments along these lines, there's experiments that's a whole other question to go into is what experiments do we have, but suffice it to say, I enjoy working on all of them. Over.
This is Steven. How long is your mission, and how do you expect it might impact your body? Over.
Hi, Steven. We come for 6 months at a time. Our mission, our particular crew actually is a little closer to 7 months, and the impact on our body is really two things. Radiation exposure is one thing we keep a close eye on, but truthfully, we're not at any more radiation dose than some high radiation fields on Earth, like a nuclear power plant worker or an airline a pilot or flight attendant. So that's in the keeping with the amount of radiation we get over our 6 months. And as well as bone density. And that's why we exercise a lot, is to keep our bones nice and healthy and dense so that we don't have rigid, fragile and frail bones when we get back to Earth. Over.
This is Adrian. What was the hardest part of training prior to going to space? Over.
Adrian, the hardest part of training is trying to keep everything straight. We have classes for about 2 years on all different aspects of coming to space, and it's difficult to remember what you learned 2 years ago right up to the end. And so I find the most challenging thing is to help keep that sorted out in your head, and what things must you absolutely memorize, and what things can you rely on basic training, but also use of a procedure for. And that comes with experience, but it's definitely challenging to absorb all the material we have to learn. Over.
This is Kira. How often do you need to do repairs on the outside of the ISS? Over.
Well, Kira, we don't do spacewalks every day or every week or even every month. I was kind of fortunate on this 6-month mission to do 4 spacewalks. We did them all in the course of about 3 weeks, I think. And then so that was the busy period of spacewalking in the middle of my mission, and then there's been none since. So depending on what's going on, it's pretty infrequent that we go outside and do a spacewalk. Maybe once every other month if you average out over the year. Over.
This is Kenzie. Describe your medical training that would help if an astronaut becomes ill or seriously injured while on the space station. Over.
Hi, Mackenzie. All of us are trained at a basic level of emergency medicine, like airway breathing and circulation kind of things, to CPR and the use of an AED, which is a device to help your heart. And then we have medication on board, but we consult the ground. If any medical situation comes up, we get on the radio and turn on the cameras and consult with our true expert doctors who are in mission control. And that's how we would deal with any situation like that. Over.
This is Daniel KNESS SSI. Standard air pressure on Earth is 1 atmosphere. What air pressure do they try to maintain on the ISS? Over.
Hi, Daniel, and congratulations on being a ham radio operator. That's fantastic. We also keep 1 atmosphere on board the International Space Station. It varies a little tiny bit depending on what activity we have going on board the space station. But in general, we keep 1 atmosphere. Over.
This is Mathew. Question for Sara. What qualifications do you have that enable you to be assigned to more than 1 mission? Over.
Well, Matthew and Sara, all of us nowadays, astronauts are all trained across the board. It used to be when during the shuttle mission you had pilot astronauts and mission specialist astronauts. These days we all get trained on spacewalks, we all get trained on robotics, we all get trained on science, we all get trained on maintenance of the space station, and so this allows our astronaut corps, or population of astronauts, really to be interchangeable on any mission that we need. Over.
This is Mathew again. Have you ever tried growing carrots or root vegetables in space? Over.
Hi, Matthew. So I have not, on the 2 missions I've been up here, grown any vegetables that I could eat. But that has happened, and other crews have enjoyed lettuce, and I think some radishes are going to soon be grown, or just recently were. So it's an interesting process to watch things grow up here. They'll grow towards the light, and we have artificial earth or watering system where the roots can take, and that sort of thing. So it's pretty fascinating to watch. Over.
This is Caleb. Are there any times where any shipments of food or drinks are running late or having spaceflight troubles, and you're out of food or water for the time? Over.
Well, Caleb, that's a good question, because food and water is absolutely essential to keep astronauts alive up here, and because of that criticality, we try to have about 6 months worth of extra food and water available at any given time, so that if cargo ships can't come, we have a cushion which we can eat or drink into. I haven't been here when that was needed, but it's something that we pay very close attention to. Over.
This is Maggie, XMPTW. How does food taste when you don't get to smell it? Over.
And Maggie, to you also, congratulations on being a ham radio operator. Fantastic. Food tastes and smells exactly the same as you would expect on Earth. My taste hasn't changed. The things I don't like on Earth, I don't like here, and the things I like on Earth, I like up here, although I really like ice cream, and we don't get to have ice cream up here. So that's one thing I'll eat in 2 weeks. Over.
Yeah, this is the last question. I give you the words on the teacher for thank you for this conversation, Chris. Teacher, go.
This is Kristen Fuqua. No, he hasn't. The teacher point of contact for ARISS on behalf of the students and staff at McConnell, as well as those around the world, I would like to thank you for your contribution to space exploration and for making lifetime memories with these students.
Oscar Romeo 4 ISS, you still there? Oscar Romeo 4 ISS, so in 4 ISS, thank you for this contact, Chris. Thank you, 7-3.
Well, Well, very good. That was a great contact. It sounds like the ISS has gone over the horizon, but I do want to thank everyone for participating. Even though he can't hear us, let's give Chris a round of applause for his efforts. And the other person that I think we give a round of applause to is should be Jan for running a very successful and a very positive contact. So thank you, Jan, for all your efforts.
Thank you, Jan. Thank you.
Yeah, okay. It was a pleasure for me to do that, so no problem.
We've all just been part of a distance learning activity featuring students from the McConnell Middle School speaking with astronaut Chris Cassidy on the International Space Station. On behalf of all of the international volunteer teams of ARISS, I would like to thank everyone for their participation. This is John, K4SQC, sending my greetings to all of you in traditional amateur radio terms and signing off. 7 3s, which means best wishes. Operator, you can stop the recording. Thank you, everyone, and good evening, good afternoon, good morning.
Thank you, John. Thank you. Okay. All right.